Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have an amazing problem for you guys, right? So it's called fruit into baskets, right? So we're visiting a farm, right, that has a single row of fruits arranged from left to right. The tree is represented by integer array fruits, right, where fruits of I is the type of fruit at that particular index, right? So you want to collect as much fruit as possible. However, the owner has some strict rules that you must follow, right? I'm saying. So it says we have two baskets, right? And each basket can only hold one type of fruit. There is no limit to the amount of fruit each basket can hold, right? Starting from any tree of your choice, right? You must pick exactly one fruit from every tree, right? Including the start tree while moving to the right. So the picked fruits must fit in one of your basket, right? So once you reach a tree with fruit that cannot fit in your basket, you must stop, right? So we'll be given this integer array of fruit, right? And we need to return the maximum number of fruits you can pick, guys, right? So this is a very interesting problem, right? So we're at a farm, and they're gonna give us a chance to pick as many fruits as possible, right? I'm saying, but the owner has some particular constraints, right? I'm saying they have two baskets. Each basket can only have one type of fruit, right? And then we have we can start from one tree, right? As we're moving to the right, right, from left to right, we need to pick from every tree, right? So we can't go in and skip trees and go into our tree. So as you're moving to right, you need to pick out from every tree, right? And if you don't like this tree that you want this tree to pick, if you get to a particular tree, right, you don't want to get it, right? You must like stop, right? And and start over at the other tree that you want to start off, right? You know what I'm saying? You can't skip a tree and try to go like that, right? No, that's not gonna work, guys. So let's go through a couple of examples real quick, right? I think that'll make a lot more sense, right? So we got this fruit array. I got 1, 2, 1, right? We got this number 3 right here. So we can pick from all three trees because, guy, right? Because we have two baskets, right? There's two baskets that we're gonna have pretty much gonna help us, right? Because we could put all the ones, right? So we have fruit. This first tree has fruits of type 1. The second tree has a fruit of type 2. And the third tree has a fruit of type 1, right? So those two fit together, right? We could put all the ones in the first basket and all the twos in the other basket, right? So we could pick from all the trees, guys, right? And it fits all of the constraints that they have, guys. We're good, right? So that will be fine. And then we got this other one, right? If we were to start picking out from zero, right? We would only have 0 and 1, right? We would not have been able to pick from the two because we only have two baskets, guys. Each basket can only hold one type of fruit. You know what I'm saying? So because of that, we would, if we were to have that scenario, it would not have been good, guys. What I'm saying, it's kind of what I'm saying. It's not good, right? So I'm better off starting from the second tree, right? Where I could pick 1, 2, 2, because those are only two types of fruit. You know what I'm saying, right? So and I could fit them in those two baskets, right? Because I have two baskets. Each basket can hold one type of fruit, right? And then this one is a little bit different, right? If I were to start at one, right, I could only have 1, 2. That's it, right? But I could not have three because I only have two baskets, right? If I had three baskets, right, I could have picked the whole from every tree, right? I could put one type of fruit in every basket, right? Because we have three baskets, but we only have two. So because of that, I have to take into account that fact, right? So I'm better off starting from two, put three in the second basket, and then put two where this two's at, and then put this two and this two's at, right? So I would have been fine. I would have had four guys, right? So yeah. So as you can see, guys, right, from those two's example, 2 and 3, right? We can't go from 0 and then 2, 2, right? No, it's not gonna work out. It tells us that as we're moving to the right, guys, we need to pick from every single tree, right? We can't cheat like that, say, I don't like number one, let me try this one, 2, 2. No, it has to be contiguous, guys. So you could think about it, right? Since it's an array, right? You need the contiguous subarray, you know what I'm saying? So yeah. So you guys already know when you guys normally hear this kind of words, guys. When you have to worry about subsequence, sub array, contiguous subarray, guys. Things that come to mind, the techniques that are needed. Because we've done many different problems that involve that kind of I'm saying thinking and logic, guys, right? So this is what I'm trying to get you guys at right now, right? So So we have fruits, right? Fruits 1, 2, 1, right? Uh, but yeah, so we need to find like so pretty much what they're saying, right? I'm saying since we can't skip stuff and we need to find the contiguous suburb, right? So pretty much the maximum number of fruits that we can have, right? Because we can only pick from one type of one fruit from every tree, right? We can't pick two, right? So pretty much the longest sequence, right? I'm saying contiguous, like sequence of trees I could pick out from is pretty much just the maximum amount of fruit that I can have, right? That's kind of what the way I'm thinking about it, right? So we should further translate, right, to make more sense to us, right? The longest, I'm saying, subarray sequence, I'm saying contiguous, I'm saying that fit that constraint, right? I'm saying so that's why I want to introduce you guys, what I'm saying, which is the way I'm trying to say it like that to kind of give you guys clues, right? Which is the thing that could play for this particular problem, right? Obviously, the sliding window, guys, right? When we need to find contiguous sequence, things like that, right? Wherever we're involved, and those kind of data structures, what I'm saying. Yeah. So the way that's gonna work, guys, obviously is gonna be we know that we have the it's a dynamic sliding window, right? So we have the right pointer that helps us in expanding the window, and we got our left, right? Keep expanding as long as our constraint is valid, right? And then once if the window becomes invalid, right, we start shrinking our window so that it becomes valid, right? And then we just make sure that we keep track of the maximum, uh, I'm saying length, right? The maximum length that we found, the maximum window length, or I'm saying, depending on the scenario that we're trying out, right? So that's why we also do that, right, guys, right? So that we can say at the end, oh, this is the maximum one, right? So by trying out the different scenarios, guys, right? And that's what I want you guys to understand, right? I'm saying and it's a very efficient way of doing it using the sliding window instead of having to do double for loops, I'm saying, or any kind of logic that's not gonna be efficient, right? So that's what I'm saying. The sliding window really helps us and solving those kind of problems, I'm saying, the most optimal way possible, right? So I'm gonna go through a couple of examples with you guys real quick, and hopefully it kind of makes sense, right? So how it's gonna work out, guys? We're gonna have the two pointers that I talked about, right? So we're gonna have this, okay. So now initially we have a max variable, right? The max variable is gonna help us in keeping track of the maximum one that we've seen, guys, right? So yeah, so now and then we can have our map, right? Our map to keep track of the frequency of that particular fruit that's in our basket, right? So that's gonna help us in knowing when we need to get rid that of that fruit because we don't have any and we could get rid of that fruit in our map, right? That's pretty much gonna let us know, okay, now we have an empty um a basket, now I could add this new fruit, right? I'm saying this is what it's going to help us. Okay, you'll see how I'm going to use it. So it'll make a lot more sense, right? So now we will start off by adding this one, right? So the maximum will be 1 now. And then we'll add this 1 to our map, right? It's going to map to a frequency of what? Of 1, guys, right? Because there's one fruit of type 1, right? You know what I'm saying? So now what we're going to do, we're going to move forward a little bit, right? We expand our expand, guys, right? We expand our window, right? So now we can add 2 to it, right? So 2 gets added. So we have 1. And then now this becomes 2, right? And then now we're gonna do, guys, we're going to keep expanding, guys, right? We expand because the constraint is still valid, right? That's why we keep expanding, guys, right? So now our window is invalid now, right? So because of that, we need to make sure we make it valid again, right? Because we can only have 2 types of fruit in our window, right? Because we have only 2 basket, right? I'm saying this is why this problem is very similar to this other problem that we did, which was the longest substring at most 2 distinct characters. Right? I have a playlist on those 2 problems. Go check that out. I think that'll make a lot more sense to you guys, right? So become now the window's invalid, right? You know what I'm saying? In our window, we only want 2 distinct fruits, right? So now, because this is invalid, right, we need to make sure it become valid. So what we do, we're gonna pretty much start, you know what I'm saying, start incrementing, you know what I'm saying, start shrinking our window, right? So now, as we're shrinking, guys, we'll make sure that we remove, right? So this will become 0, right? Which means that we would need to remove the 1 out of um out of the map, right? So now I'm saying we add the 3 now, right? Since we're gonna take into account. So we add the 3. There's only one of that type 3, right? So we add 1. And then now we're gonna pretty much expand that, right? It's still valid, guys, right? Because now we have 2 of the type 2s, right? So now, right, we become 2, right? I have a map right now that's taking track of it, so you guys can't see it, but there's a map doing that, right? So I'm just having it that way instead, right? And yeah, what we're gonna do, so now we have 202, so now our maximum, right, obviously is gonna change to 3, guys, right? Because that's maximum we've seen, right? I'm saying that's our window right now, right? Okay, so now what we're gonna do, we're gonna expand again. So now this is gonna change to 3, right? Because we have 3 of the 2s, right? And then now the maximum becomes 4, guys, right? I'm saying just like that, we're able to have our answer, which is a 4, right? I'm saying. So yeah, let's quickly go ahead and implement the logic real quick. All right, hopefully you guys are able to understand everything. And yeah, let's just quickly go into it, guys, right? So we're gonna have a map, guys, a map that's gonna pretty much help us in keeping track of the frequency of the fruits, right? I'm saying different types of fruits, guys, right? Which is very, very similar to the R problem guide, pretty much a copy and paste of that, right? So now we're gonna have our pointers, guys. So we're gonna initialize our left pointer, right? And yeah, by now we know the roles, all right? All right, right, plus plus, okay. So now we're going to have fruit left, right? Fruit right, actually, right? Because we're gonna expand with the right, right? Like we said, and then fruit of the right. Um, so we get that fruit that the right pointer is pointing out, right? And then we are going to put it in the map, right? We add an entry for it, right? Get our default. It's gonna, and then we put fruit right, right? And then we increment that right there, right? And then now, guys, right? We also need a maximum variable, right? I'm saying, right? Okay. And then we got a maximum variable is always going to be mapped at max of the max currently or this new updated length, right? That we've just found, right? You know what I'm saying? Um, so this is I do the plus one, right? Because obviously, arrays are zero index, right? Base. So that's why we need to add the plus one to account for it, right? Because yeah. Yeah, so once we have that, guys, so now we need to, when do we shrink, guys, right? That's the question you should be asking right now, right? So we shrink when the constraint becomes invalid, right? It becomes invalid, guys, right? Right? When the size of the map, right, becomes a certain size, right? When it becomes 2, guys, right? Because, guys, right? Uh, we can have only 2 types of fruit, with pretty much 2 distinct fruit at one time, right? So as we're trying the different scenarios, right, we need to make sure that we don't go over that constraint, right? If we do, we're gonna have to do something about it, right? So fruit left, the left corner pointing out, right? And then what we're gonna do, just copy this. We're gonna, as we're moving to the, as we're moving to the as we're shrinking, guys, we need to decrement it, right? Because we're going to move the left corner. So we're not going to be accounting for that fruit anymore, right? For that particular fruit, that particular tree, right? So that's why we need to decrement the frequency of that fruit in the map, right? I'm saying. And then now we do a simple check, guys, right? If the right, if that's equal to a 0, right? We're gonna pretty much remove it, right? There's no need for that fruit anymore since I have none of it, right? So I don't need to keep track of it anymore, right? So I could easily remove that guy, right? And then to make sure, also always make sure that you do left plus plus, guys, to move to, so it knows that you actually left that fruit, right? Exactly as we were doing in that walkthrough, guys, right? Hopefully you guys make sense. Let's press run code, see if we miss anything. Looks good to us so far. Let's press submit, guys. Awesome, guys. We were able to pass all the test cases, guys. So I want to thank you guys for watching this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.